this is Kai from MBUSI, and I'd like to welcome you to our final webinar of this MBUSI Innovation Challenge, webinar number 8 for our automated kitting and sequencing using robots, of course, in our part storage areas. I would like to welcome our subject matter expert, Adam, here with us from the supply chain area, who will, in a second, go over the actual problem statement and some additional information that they have compiled for your information. Right after that, we will then transition into the Q&A section of this webinar, where you have the chance to ask some live questions right now directly to our subject matter expert. Feel free to already start typing the questions in the little Q&A bubble at the bottom of your screen now, and we will then get to them later on in this webinar and answer your questions. With that being said, though, I'd like to hand the word over to Adam.
So hi everyone, my name is Adam, as Kai mentioned, and I am responsible for sequencing in our warehouse that's attached to Assembly 2. And our use case that we selected is specifically for our sun visor labels. You all have seen the labels in your sun visors that tell the different warnings for the vehicle. As you can imagine, we ship cars to a lot of countries, and if we had a different sun visor for every label that we had, our number of variants would be astronomical. So we basically label our sun visors individually inside Assembly 2, and this is the use case that we have chosen to provide for this topic. Hopefully you all have seen the PowerPoint or have the PowerPoint access to view it that I provided, and you can see the layout on slide number 4 of our sun visor label station inside Assembly 2. The top left of the picture is a sun visor label machine. The very top is the gravity feed conveyor. You can see a picture on the bottom right of this conveyor. And then you can see the sequence racks sitting on their dollies. There are 5 of them in the picture, but in the drawing, they're just sitting there. They're in no particular order. The process for this particular process is the sun visor set boxes, which are the small gray totes that you can see in the in slide number 5. These small gray totes or set boxes are pulled out of the roller conveyor style sequence rack. They're placed on the conveyor, 12 set boxes at a time. Then the team member picks the sun visors out of the set box, puts in the label machine, where the label machine spins around four different sun visors at a time, and then the parts come back out of the label machine, where they're put back into the set boxes on the conveyor bed. Then the set boxes are placed back into the sequence rack. This is the process that we would like to replace with a robot to see how this can work, to see how it can work with our system, and also to understand if the gripping device would cause damage to the sun visors. I provided pictures of the sun visors in slide number 5. You can see the sun visors in the tote. Each sun visor is on the extremity of the tote. In the pictures, I have black sun visors and beige sun visors. Then I took some pictures of the sun visors themselves, so you can see the pictures of the labels that are placed on the sun visors. The very last slide is a picture of the rack load label. This rack load label, we have this in a PDF form. We can provide to the robot should it want to read the actual part numbers associated with each slot in the set boxes. But I guess this is really a topic if you guys want to incorporate that into your process or not.
Okay.
So I hope that was a fairly decent explanation.
Mm-hmm. Absolutely.
And if you have questions, please ask.
Okay. Thank you, Adam. So we already have some determined questions that we received in advance. So let's jump straight into those. Is there a specific brand of robot that must be used?
Not a specific brand, but the robot should not damage the parts. These parts are, let's say, like maybe an eggshell. The outside is a little bit hard, but if squeezed tightly, it could damage the parts and make indentations or creases in the actual sun visor material.
Okay.
So no specific robot is in mind.
Mm-hmm. How should the robot pick the parts? By color or by shape or any other factor?
The robot should pick the parts. First, it should know what the parts are that should be in there based on the picking list. Then it should have an idea of what those parts are, color and shape, to know how to look for it. The robot should also be so intelligent as to determine how the team members place the sun visors into the set box. The sun visors could be placed any of 4 directions, and you have a left sun visor and a right sun visor. So the robot should be intelligent enough to distinguish between.
Okay, and I think that was also one of our requirements on the one-pager, where it said that it should potentially include a vision system to validate picked parts and distinguish different colors and such. Okay, what kind of space would the robot be operating in? And I think you already touched it a minute ago when you showed that little picture. Maybe we can go back to slide number 4 and look at that cell, the cell layout.
So I can get dimensions of this and provide a more detailed drawing if anybody needs. But the current space is, I would say, we have some wiggle room in the space, but I would say it would need to fit in a 6 foot square, so 6 by 6.
Okay. How many different parts are there to choose from?
So for this particular topic, the parts are already in sequence. We just need to understand, can the robot pick the parts out of the container and put them back in the containers in the same sequence? And the way the current conveyor bed works, there are basically 4 slots that are active at a time. So the first group of sun visors goes in the machine, the second group of sun visors, third group, fourth group, and then once the fourth group goes in, then it's time for the first group to come back out, where the robot would then need to put the parts back in the first set box that it pulled from.
Okay. So just to clarify, I think for this first idea or use case that was identified here, we're just talking about one particular part. So it's not a box or a selection of many different parts. It's basically just the sun visors. So that already explains a little bit the next question. What is the size range of these parts? Of course, since it's just a sun visor, so it's a typical sun visor dimensions. Okay. How often are the part picking schemes changed?
So every car is different, but it could be that we build 3 black, 2 brown, 1 gray in a row. So it's basically every car gets a sun visor, and really it's just the color and the shape of the sun visor, but they're pretty well all very similar in shape and size.
Okay. Can there be any cloud interaction? So I might jump into this question from an IT standpoint. So as of right now, we are not permitted to use any cloud-based services. There is a process to get an exception to this, but for now, you should be planning on not having any cloud-based services available at that time, or using any cloud interaction. Okay. Can you talk about why current robot solutions do not work?
We really don't have any current robots. This would basically be our first robot use case in the plant in regards to picking actual parts that we deal with as supply chain. But if this works, if we can make this work, there are almost 100 other KSLs that could be potential use cases in the future. So the idea is to make this use case work, and then we can grow that topic to the MLC, where we have, like I said, almost 100 sequence cells.
Yeah, and that leads us already to the next question. Is this just an example of a kitting sequencing task, or are there other non-sun visor tasks as well? So I think, as you mentioned, for this specific task or project right now, they decided to only go with this specific use case. But as Adam mentioned, potentially there are many other cells and areas in the plant that where we would like to use robotics in the future as well. And this would just serve as the initial proof of concept, so to speak, to see how it goes and how it works. But any company that would win competition and get their POC approved for this, of course, will then have a great chance to expand on that and implement this in, I think as Adam mentioned, over 100 different sequencing cells as well, or cells, picking cells, I guess, and as well. The next question, SAP was mentioned. How does data get to and from SAP, and how important is this?
So we sequence the parts in the SunVisor cell from SAP. It's a specific SAP function that we developed. And you can see in slide number 6, an example of output from SAP that I mentioned that we could provide in a PDF in the event that the robot wanted to read the PDF. As far as a middleware between a software from the potential vendors and our SAP, that's a tricky topic, and it's in the past not been able to be done.
Mm-hmm. So for this specific use case, there is no SAP interaction. So no direct connection to SAP required right now. The information comes manually out of SAP in the format of either a paper or a PDF sheet. Is that correct? Okay. If you have more questions, please don't hesitate to ask them. I will start moving on now to the next section, the last section. Just some final words I'd like to remind everybody with. Of course, unfortunately, we had to delay this webinar a little bit. So if you have not registered for the challenge itself, please do so by today. Today is the actual registration deadline, just to get your name in the hat. That does not mean you have to have a submission or proposal yet. Our actual proposal deadline is May 18th. So that would be this Friday. So by May 18th, end of business is when we will stop accepting any of the proposals. Then as a next step, we will inform the semi-finalists by May 22nd. Semi-finalists will be invited to our plant here at MBUSI to interact with the subject matter experts and also get a chance to potentially see a location for the actual use case and where the proposal would be applied to. If you have any questions, please don't hesitate to contact us at mbusi@urbanengine.com. You can also find our Slack space out there where you can, so to speak, in real time, more or less, communicate with us and with our partners at Urban Engine. So we're really looking forward to your proposal. Keep in mind, this is a really good opportunity for you guys to get your foot in the door at a major Mercedes-Benz production facility. Of course, the prize, our grand prize here is funding for an actual proof of concept that would just get you started here potentially. And if that works, then you would have the chance, of course, to become a permanent vendor to MBUSI. Your proposal can be in any shape or format. So it could be a slide deck, it could be a video, it could just be an elevator pitch. This is really up to you. Whatever you think brings over your message in the best possible way. Also, one of our great prizes is the chance to participate in a Startup Autobahn pitch event in Germany. Startup Autobahn is our partner that was created by Daimler, of course, Mercedes-Benz's parent company in Germany, together with a bunch of other companies such as Porsche, BASF, and a whole ton of other automotive suppliers from the industry. So they hold an annual event over there where you would be invited to participate, to pitch your idea to all these decision makers from all these different companies. If you need more information, feel free to go to startupautobahn.com and read up on their program. With that being said, we thank you for your participation and really look forward to your submission. Thank you.